Okay, in this video, we look at doing hypothesis testing when our data is not real numbers, when all we have are counts. And the only way that happens is that when you have categories of data, or your data is categorical, nominal in nature, then all you can do is count it. Well, the best you can do is determine if the observed results are what you would expect to get. What I mean by expected is that what would you expect to get if they were not related? Here's our data set. We have some data that shows that people smoke, and they're either non-smokers, heavy smokers, or something in the middle, and they had an accident. And I want to know if there's a relationship between this and this. Now, these aren't real numbers, they're counts, but that's what I need. I need to use counts, or I'm going to use a chi-squared test. That's what this means. This is chi-squared. What we do to calculate that is we calculate this term observed minus expected squared divided by expected. And then for how many of those different categories we have, we sum those up. So to get the counts, we can use a pivot table. And I'm going to drop the smoke into one, accidents into the other. I can get a count. And just like that, this is the data that I need. And that's really all I need is this. Now I'm going to hide these. I don't really need them anymore. And all I'm left with then is this is what really happened. This is observed / actual. It's the same thing. It's the what really happened. Now I'm going to grab that, copy it, bring it down, and now I want to actually calculate, well, what did I expect to get? How do I calculate expected? Well, it really depends. It's expected, and this is if smoking and accidents are independent. What would I expect to get if there was no relationship? You can calculate this by taking the row total times the column total divided by the overall total. So in this case, for the very first row, the first column, I take the row total multiplied by the column total divided by the overall total. Now I'm going to hard code the column D and the row 15 and copy that for all of my numbers. And this is what happened. This is what I would expect to happen if they were independent. So from that, I can calculate my chi-squared numbers. So these will be my chi-squared stats. And how you calculate those is you take the observed, and I'll show you, observed minus expected divided by the expected. Observed minus the expected, square it, divided by the expected. I got 6 of these. So there are my numbers. And now my hypothesis test that I'm doing. Step 1, H0, smoking and accidents are not related. We don't assume they're related, we assume they're independent. And then our next one, our alternative, is that smoking and accidents are related. We set an alpha, we calculate our chi-squared number, and it's just the sum of these 6 numbers. Like that. Step 5, calculate a p-value. We're going to use something, we're going to use the chi-squared dot test. That's how we can do this. If you backwards compatible, you can just look at that. That'll do the same thing. Chi-squared dot test. Calculate, grab the actual range, and again, not the totals. Grab the expected. In parentheses, it gives you a p-value. Since the p-value less than alpha, not by much, but it is. We reject the null hypothesis, and that means that the null hypothesis is not true, so we can assume that smoking and accidents are related. We're not saying one causes the other yet. That's the further steps, but this is all we're going to cover for this class. Thanks.